All right, in practice example 15.5a, it says equal masses of carbon monoxide, water, and carbon dioxide and hydrogen are all mixed at a temperature of about 1100 Kelvin. And when equilibrium is established, which substances will show an increase in quantity and which will show a decrease compared with the initial quantities? That's the question. So we have equal masses being brought together in this volume. We have to decide on what volume. Let's make it 1 liter to make it easy. And equal masses. Well, let's make it easy and say that we've got 10 grams of each. And in order to determine in which direction, because that's really what the question is asking you, in what direction will the reaction go in order to reach equilibrium? So if it moves forward towards the products, then these quantities at equilibrium will be less than those present initially. And if it moves towards the reactants, so if Q is bigger than K, then these quantities will be less at equilibrium than they were initially. That's what the question is asking. So what we need to compute is a reaction quotient using those initial values and compare it to K. So if Q is bigger than K, we know the reaction is going to go from in this direction. If Q is less than K, the reaction is going to go in this net direction to reach equilibrium. And of course, if they're equal, it's not going anywhere. It's already at equilibrium. This is already balanced. We want to check to make sure that's the case, but it is. And we want concentrations of each one. And so let's start with carbon dioxide. 10 grams over, I'm just going to write 44 grams per mole. This question is not about being precise, but having an idea of which direction it goes in. So that's my number of moles, and all of that is over a 1 liter flask, so that's my concentration of carbon dioxide. And I'll do the same thing for hydrogen gas, so 10 over, say, 2.0 grams per mole. And let's put that in a 1 liter flask as well. And that will be all over 10 grams and 28 grams per mole for carbon monoxide. And 10 grams or 18 grams per mole for water. Now the thing about this question is that all those terms have no exponents, or the exponent is 1, and so I can do some quick cancellation here. And all of the 10 gram quantities will actually cancel out, and all of the 1 liter quantities will also cancel out. Just going to lift this up and move it up a little bit here. And it's only because all those stoichiometric coefficients were 1 for each species that the cancellation is nice and tidy. So in fact, what I have then for QC, let's check the calculations, is 28 times 18 divided by 44 times 2. And so I get a QC value that's equal to about 5.7. And when I compare it to the K, I find that it's greater than the Kc, which of course was 1.00. And therefore, the reaction will proceed in a net direction to reach equilibrium, and that net direction will be, which way will it go? Towards the reactants or the products if Q is bigger than K? To the left, towards the reactants. And therefore, sliding this back down, if it goes to the left in order to reach equilibrium, then these quantities will be greater than 10 grams at equilibrium, and these quantities will be less than 10 grams at equilibrium. Okay, so again, the question is a little bit simplified because the cancellation was very straightforward, and the only reason that it was so straightforward was because we had coefficients of 1, 1, 1, and 1, and therefore that made powers of 1 everywhere. But if these powers were not 1, that cancellation would not be so straightforward. So be careful of that on the exam.